Hi guys, welcome back. Today we are going to be rationalizing the denominator, and if there's a round 1, I guess there's going to be a round 2, so stick around. Okay, so rationalizing the denominator. So you can read, but I'm going to go ahead try to illustrate by example. So with problem A, it says rationalize the denominator, whatever that means, and then my favorite disclaimer, assume all variables represent positive real numbers. And this is my favorite disclaimer because when we are told that if we have a variable, let's assume it represents a positive real number, then we don't have to worry about tossing in an absolute value to ensure that the radicand is positive when the index is even. Okay, I've said too much because I'm an overachiever. Okay, rationalize the denominator. Pretty much, we have problem A, and if I ignore the directions, let's just pretend that the direction says simplify. When it comes to radicals, how can I tell if the expression is simplified? If you have a fraction, make sure that you don't have a radical in the bottom. Okay, so that was one of our items. Okay, now the question is, how do I get rid of the radical? When we have a radical in the denominator, then the denominator is irrational. We want to get rid of the radical. So when we get rid of the radical, the irrational number magically turns into a rational number. Okay, I think I've said too much in an effort for me to break down what rationalize the denominator means. So in English, rationalize the denominator, straight to the point, is code for make the denominator a rational number. In English, get rid of the radical. Now the question is, how do we get rid of the radical? Let me go ahead and write down problem A. So if I know how to count, we have 1, 2, 3, 4, 5 problems. Let me go ahead and write problem A with you. So we have 5 times the square root of 3 over the square root of 5. Okay. The question is, how do I rationalize the denominator? Okay, so to rationalize the denominator, first you have to ask yourself, how many terms do you have in the denominator? If you have one term, then this is how you're going to handle it. If you have 2 terms, then you got to wait for round 2. Okay, but if you only have 1 term and you want to get rid of the radical or rationalize the denominator, pretty much you have to multiply top and bottom by an equivalent form of 1. So it makes the radicand a perfect square. Okay, and I say perfect square in the event that we're working with square roots. Okay, if the index was 3, multiply top and bottom by an equivalent form of 1, so it makes the bottom a perfect cube. I think what I said is just I don't know if I conveyed what I was trying to say, but I know that I will convey my message when we actually do the problem. Okay, so problem A, rationalize the denominator, code for get rid of the radical in the bottom. So question that I'm going to ask myself is this: how many terms do I have in the bottom? 1. Okay, cool, just 1. That's my kind of problem. So I'm going to identify the exponent in the radicand, which is 1. Okay, let me go ahead, zoom in. So pretty much I want the radical to be gone, so I'm going to see how many factors do I have of the base is 1. And now how many more factors do I need to get to 2? Well, if my eyes don't fail me, to go from 1 to 2, we just need one more factor of 5. So we're going to multiply top and bottom by one more factor of 5. Well, it's not really like a factor of 5. That's just how I speak. Okay, we need another 5. Okay, so essentially we're going to multiply top and bottom by the square root of 5. Okay, so when we do, square root of 5 times itself will give us a square root of whatever your heart desires. You can either multiply the radicands to make 25, or you can write it as 5 squared. It's a personal choice. I really don't care, but I'm going to go ahead, just, you know what, we'll multiply the radicands. 5 times 5 will give us 25, and the square root of 25 will give us 5. Okay, so we have rationalized the denominator. I'm not a big fan of writing across, but in this case I am going to. Okay, so I'm gonna refrain from the equal sign because I don't want to have so many equal signs in one line. Okay, so looking at the numerator, let's multiply 5, square root of 3, and the square root of 5. When we multiply the radicals, square root of 3 times the square root of 5 will give us square root of 15. So that will leave us with 5 times the square root of 15 over 5. Okay, so the directions read rationalize the denominator. So that's code for like make the denominator a rational number, or in English, like get rid of the radical. Radical is gone. So we could get rid of the radical in the bottom, but we can't just get rid of it from the problem. It just, your math will tell you, if when you have your leftover radical, make sure it's simplified. And in this case, the square root of 15 is simplified because 15 doesn't have a perfect square factor. So we're cool. Now ultimately, this bad boy is still a fraction, so we still have to ask ourselves, is this bad boy reduced? And the answer is no. Why not? Well, that's because the top and bottom have a common factor of 5. So let's work our magic. So we're going to go ahead, cancel out the 5s, and that will leave us with the square root of 15. Okay, so our goal was just to rationalize the denominator or make the denominator a rational number, but it turns out we just got rid of it. It's not always going to be like that. So that was one. I guess we have 4 more. So let's go ahead, write down the next one. Problem B, we have -10 over cube root of 2. Okay, something that I wanted to point out that I forgot in the previous problem. Sometimes students want to cross cancel things when they shouldn't. Like in problem B, you may be tempted to cancel out 10 and 2 by a factor of 2. For problem A, you may be tempted to cancel out the 5s. But check it out, you can only cancel if the factors are both outside the radical or if they're inside the same radicand. Okay, so just be careful. Out, without, in, within. Okay, problem B. Okay, so I want to point out that all the problems that we're going to tackle today, they are going to just have one term in the radical. Okay, but on the test, you don't know what you're going to have, so I'm just going to ask the questions from the beginning. I want to act surprised. Ooh, how many terms do we have on the denominator? I feel like the more I repeat myself, I'm hoping that the more likely that it will stick to you. I hope I say what I wanted to say. Okay, so from the beginning. Okay, problem B, the directions rationalize the denominator. Okay, make the denominator a rational number. English, get rid of the radical in the bottom. Cool. How are we gonna handle it? So let's ask ourselves this question. How many radicals, how many terms do we have in the denominator? In this case, we only have 1. Okay, cool. How many factors do I have in that radicand? Okay, like what's the exponent? 1. How many do I need overall? Well, the index is 3, so we need 3. So I'm like, how many more factors do I need to get to 3? Well, if I have 1 to get to 3, we need 2 more. So let's multiply top and bottom by 2 more. Okay, by 2 more of those factors. Okay, so 2 to the first times 2 squared will give us 2 to the third. Okay, so we're going to multiply top and bottom by 2 squared. I'm going to go ahead, attack, and simplify the denominator. As you evaluate the radicals, you write however it suits you. If you want to write down 4, that's fine, okay? But the reason why I leave it in prime factored form is because it highlights like how many more factors do I need. Like if I got 1 factor of 2, I need 2 more factors of 2 to reach 3, okay? Product of 2 and 2 squared, silly exponent rules, they make me so mad. And if you don't have no idea what I'm talking about, I'm crying because that means you didn't watch a video from like 3 chapters ago, I think. Okay, so when we're multiplying 2 things that have the same base, we're gonna keep the base and add the exponents. Okay, so the base is 2, and then we're gonna add the exponents. Do you really have to leave it in factored form? You don't. Okay, if you just want to multiply the radicands, 2 times 4 is 8. Go ahead, evaluate cube root of 8. But for me, it's so much easier to evaluate cube root of 2 cubed versus cube root of 8. Okay, so that's just my take on it. So at this point, index is 3, power is 3, the cube and the cube root undo each other, and that will leave us with the radicand of 2. Okay. The directions read rationalize the denominator. So in English, get rid of the radical in the bottom. And we did. Let's go ahead, write down what we have. So in the numerator, we have product of -10 and the cube root of 10 squared. So -10, I think I said cube root of 10 squared. My mistake. -10 times the cube root of 2 squared. We cannot simplify 2 squared, so then with confidence, we're just going to square it. Okay, the square root of 2 is 4. And then all over our freshly rationalized denominator of 2. So the radical is gone in the bottom, so we have followed the main instructions. Ultimately, this is still a fraction, so we have to see is it reduced, and the answer is no. Why not? Well, that's because the top and bottom have a common factor of 2. So let's do this. 2 goes into itself once and into 10 5 times. Let's bring up the negative, and then after all our hard work, that will leave us with negative 5 times the cube root of 4 all over nothing. Okay, the denominator is gone. Okay, we box our answer, so that's it. I'm going to take the fraction bar and make it as part of my box. Alright, we got 2 problems down, a few more to go. Problem C. Problem C, we have negative 8 over square root of 18. Okay, the way the problem was originally presented was it's not negative 8 over that, it's just a negative fraction. But I put it with the top because that's just where the negative landed. It's okay. One of the worst things you can do to yourself when it comes to rationalize the denominator is just right away multiply top and bottom by whatever you see. What I recommend is you simplify the radical first and then work your magic to rationalize the denominator. So we got square root of 18. If the numbers come to you, let's see if you can think of a perfect square factor. And a perfect square factor of 18, I believe, is 9. So we're going to write this as square root of 9 times the square root of 2. Evaluate what you can and do what you got to do. Square root of 9 will simplify to 3, and that is being multiplied by the square root of 2. So we have yet to rationalize the denominator, but the thing is, would I rather work with 18 or would I rather work with 3 and 2? Okay, I think I could guess your mind. Okay, read your mind. Let's go ahead and write down what we have. In the numerator, we have a negative 8. In the denominator, we have the simplified form of root 18, which is 3 times the square root of 2. So now the $1,000,000 question, how am I going to rationalize the denominator? So I'm going to ask myself, how many terms do I have? 1 or more than 1? In this case, we have 1 term. Yes, we have 2 factors, 3 times the square root of 2, but it's still 1 term. It's not like we have something plus something or something minus something. So when we just have 1 term, to get rid of the radical, we just ask ourselves, what is the index? 2. Okay, how many factors do I have in the radicand? 1. How many more factors do I need? 1 more. Okay, because 1 plus 1 is 2. So we're going to multiply top and bottom by another factor of 2. Okay, well, it's a factor of square root of 2. That's just how I speak. Okay, just 2. 1 more factor. Sorry. Okay, this is why we use pencil. So let's go ahead, simplify this. Product of 3 square root of 2 and square root of 2 will give us 3 times. Because we have square roots, I'm going to just go ahead and multiply the radicands to make 4 versus using exponents or repeated factors. Product of 2 in itself will give us 4. So the square root of 2 times the square root of 2 will give us square root of 4. Last time I checked, the square root of 4 simplifies to 2. And the product of 3 and 2 is 6. Okay, so let's go ahead and bring down our problem. In the numerator, we have negative 8 times the square root of 2. And the denominator, after all our hard work, after all of our hard work, okay, I think I said that right, that gives us 6. So I'm crying, okay, tears of happiness. Okay, so we have rationalized the denominator. We have made the denominator a rational number. In English, we have gotten rid of the radical in the bottom. The radical that remains is already simplified, but we still have a fraction. Okay, so we have to ask ourselves, is it reduced? And in this case, the answer is no, because the top and bottom have a common factor of 2. So let's do this. 2 goes into 6 3 times and into 8 4 times. So let's just go ahead, write down what we're left with. In the numerator, we have a negative 4 times the square root of 2, and that's all over 3. Okay, the first 2 problems, after we rationalize the denominator was gone completely, but that's because that's what the numbers gave us. Okay, but the denominator is not necessarily always going to be gone. I mean, just follow the math. Okay, follow the math and the math will tell you. As long as the radical is gone in the bottom, then you're good. Okay, for the almost grand finale, let's go ahead and knock out problem D. Okay, problem D, we have negative, oh, you cannot see D. Problem D, we have negative cube root of 15 over 32. So the radicand is a fraction. So with your permission, I'm going to put the radicand first. and then the radical sign. Then we'll highlight the index, and then we'll write down the negative. So we want the negative cube root of 15 and 32. So I'm like, okay, the directions read rationalize the denominator. Now, right now we don't have a denominator. We just have like the cube root of this fraction. So what we're going to do, we're going to use the quotient rule for radicals to split the top from the bottom. So we're going to write this as quotient of the numerator, cube root of the numerator, over cube root of the denominator. And let's make sure that we don't forget the negative sign. Okay, so you have ways to go about it. You can just work your magic to get rid of the radical, but again, love yourself. Look at what we did with the other problem. Before you think about what do you have to multiply top and bottom to rationalize the denominator, go ahead, simplify the radical first, and then ask yourself that question. So cube root of 32, I have no idea what a perfect cube factor is, so we're going to write 32 as a product of prime factors. With your permission, I'm just going to give you the result, but you can do the factor tree on your own. So 32 is the same as 2 to the 5th power. 1, 2, 3, 4, 5. Okay, do you have to do it like this? No, but this is like my favorite way of doing it when the numbers don't come to me. Now it's time to make some groups. Since the index is 3, we want to make groups of 3, and everyone needs to wear the same suit. Okay, so we gotta be triplets. 1, 2, 3, and then we don't have enough 2s to make another group of 3, so we're gonna have some solo riders. Whoever is in the group gets its own radical, and the solo riders, they all get tossed in its own radical. Okay, so we have cube root of whatever your heart desires. You can evaluate 2 times 2 times 2 to make 8, but with your permission, we're just going to go ahead and use exponents for repeated factors. So 2 to the 3rd power. Why? Because I would rather take the cube root of 2 cubed versus cube root of 8. Same difference. And then the solo riders, let's go ahead, toss them in a separate radical. Now you have some options. You can simplify the product of 2 and itself to make 4, but I recommend you leave it in prime factored form because that will allow you to work with smaller numbers. Trust me on this, okay? I know what I'm doing, okay? So let's keep doing this. Cube root of 2 cubed, index of 3, power of 3, they undo each other, and that will leave us with the radicand of 2. And what's going on with that 2? That is being multiplied by the cube root of 2 squared. Okay, so let's go ahead and bring that to our table. So we have cube root of 15, I almost forgot the negative, over the denominator, which has been simplified to 2 times the cube root of 2 squared. Fantastic. So now the question is, how am I going to rationalize the denominator? So let's ask ourselves this question. How many terms do we have? 1 or more than 1? So in this case, since we only have 1 term, we're just going to identify the index, see how many factors we have, and then ask ourselves how many more factors do we need to get to match the index. Index is 3, so we need 3 factors in order to cancel out the radical. We got 2 factors, so to make 2 to go from 2 to 3, we need 1 more factor of that base, so we need 1 more factor of 2. So let's go ahead and multiply top and bottom by 1 more factor of 2. Cool. Okay, so it's just cube root of 2. So when we do, let's go ahead simplify the denominator. So we have integer factor of 2 times product of the radicals. When we multiply the radicands, 2 squared times 2, we're going to keep the base at the exponents, and that will give us 2 to the 3rd power, or you can write 8, whatever your heart desires. Cube root of 2 cubed, the index of 3 and power of 3, they undo each other, and that will leave us with the radicand of 2, and that was being multiplied by the integer factor of 2. Product of 2 in itself is 4, so the denominator has been rationalized. Okay, we have made the denominator a rational number, or in English, we got rid of the radical. Okay, let's go ahead, simplify that numerator. Okay, so we have negative cube root. I'm going to just write 15 times 2 instead of giving the simplified product of 30. And that's all over 4. Okay. The reason why I left it as a multiplication problem versus evaluating is because I want to know, like, is this radical gonna be simplified? Well, 15, if we prime factor it, that's gonna give us a 3 times 5, I think. So we have 15, or 3 times 5 times 2. And now the question I'm gonna ask myself is this: is that top radical simplified? And the answer is yes. Why? Because, oh, the negative. I think I'm gonna start circling the negative so I don't forget. Okay, so is that top radical simplified? And the answer is yes. Why? Because the index is 3. So if we were able to simplify, we would have to be able to make a group of 3 where everyone is wearing the same suit, but we can't make a single group of 3. So that means that the cube root of 30 would have been simplified already. Okay, so that gives us negative cube root of 15 times 2, or 3 times 5 times 2 will give us 30, and that's all over 4. So I'm gonna box this and then say like the wrap-up questions for this problem. Okay, so I already boxed this, so I'm telling you that it's done. Okay, but the question is, am I done? Yeah. Okay, we have rationalized the denominator. We have made the denominator a rational number, or in English, we got rid of the radical. The radical that exists, it's already simplified. And lastly, this is a fraction, so we always have to ask ourselves, is it reduced? 4, there's nothing to cancel it. There's nothing to cancel it with. So that's it. Okay, so we're good. So I said we were gonna do 5 problems. There's typed up, so I can't back down. That was our 4th problem. Let's go ahead and do our 5th and final problem, and then we're out. And we're back. Okay, so problem E, we have 4th root of 6y over w, and the directions are rationalize the denominator. Okay, so what we're gonna do, we're gonna go ahead split the top and bottom by using the quotient rule for radicals. So that will give us 4th root of the numerator over 4th root of the denominator. Fantastic. So to rationalize the denominator, or to get rid of the radical in the bottom, the question that I'm going to ask myself is this, because depending on the answer, that will determine the strategy that we will use to rationalize the denominator. So the question that I'm going to ask myself is this: how many terms do I have? Do I have one term or more than one term? Fortunately, we only have one term. So to rationalize the denominator, I got to ask myself, what is the index? So how many factors do I need? Okay, index is 4, so I need 4 factors of that base. Okay, what is the exponent on the base, or how many factors do I have? Okay, exponent on the base is 1. So I'm like, okay, I need a total of 4 so the radicals could cancel out, because the speech will be index is 4, power is 4, they undo each other. Okay, but we got 1 factor of w. Guess what? We're gonna need 3 more factors of w. So let's go ahead and multiply top and bottom by 3 more factors of w. But supposedly you can read my mind. Okay, I don't say it correctly because it's just easier for me to say 3 more factors. Okay, but we're gonna multiply top and bottom by 4th root of w cubed. Okay, let's have good notation. Okay, if we say it wrong, at the very least we need to write it right. Okay, so let's simplify the bottom and then confirm that the radical is gone. Okay, so let's go ahead and use the product rule for radicals. So those we're gonna keep that index w times w to the thirds. Again, silly exponent rules, they make me so mad. So we're gonna keep the base and add the exponents. 1 plus 3 is 4. Cool. Now we have reached our goal. We wanted the radical to cancel out, and the only way we would is if the index and that power were the same. So index is 4, power is 4, they undo each other, and that will leave us with the radicand of w. Okay, no more exponents, no more radical in the bottom, so we're good. So we got a w in the bottom, and then in the top, let's go ahead and multiply the radicals. So that will give us 4th root of 6y times w cubed. 6y times w cubed. Okay, so I'm gonna box it. So pretty much I should box it after I say my piece, but I want to put my pens down. So my pens. Okay, so I'm gonna ask myself, is this bad boy like simplified? So I'm like, did we rationalize the denominator? Did we get rid of the radical in the bottom? We sure did. Okay, The radical that exists, is that simplified? Yeah, because we cannot simplify 4th root of 6yw cubed. And then lastly, this is a fraction, so is it reduced? And I cover up the radical because if I could reduce, I'm supposed to be able to cancel w with something else, okay? So it's a fraction. Is it reduced? And the answer is yes. Okay, guys, so as promised, we knocked out 5 problems. So for those of you that are asking, how are we gonna rationalize the denominator if we have more than one term? Well, you have to come back for round 2. I should be like a writer where they leave you in a cliffhanger. Thanks. I think I just did.